Hello everybody, my name is Dominic from Naneos. I'm in home office due to well-known reasons, and I would like to talk with you about a topic that is perfectly made for home office. It's the Naneos IoT sensor platform where you can watch and analyze your measured data online, also in real time. This video will be about the front-end website, so more a walkthrough to the website, how to analyze data, how to download data, what you can do with all the front end. And if you're interested in the general technical thing behind this IoT sensor platform, I have linked here a short video on top that is more an overview about the complete system. Here, now we focus only on the front end website that is available through the internet. So I have also added some timestamps below, so if you would like to jump to a certain topic, and yeah, that's it. So let's go. If you go to our website, naneos.ch/iot.html, and scroll to the bottom, there you can find a link to the guest front end with login data. As you can see, we use the powerful Grafana framework. And if you are logged in, you might already see some graphs. If you have a freshly set up account, it looks a bit different. So let's quickly dive into how dashboards are organized. If you click on the side, dashboard, then manage, you can find the dashboards you have access to. We have two standard dashboards, one for data visualization and analysis, and one dashboard for downloading the complete raw data. I will later on focus on this topic and the reason why we have two separate dashboards here. So let's open the default dashboard. You see there are some plots of measured data here. Now on the top left, you have a drop-down menu where you can select your sensors. Either you select one to view a specific sensor, or you can select all of them to get an overview of all your sensors. The sensors have to be mapped to your account by Naneos, so please let us know your device serial numbers. On the top right side, you can select a time interval. You can also do that by zooming inside the graphs. On the top right side, you can also select the data refreshing interval if you want to continuously see real-time data coming in. As you can see, we have here a long deposited surface area, number, concentration, and mean particle size. Also, PM 0.3 ultrafine particle mass. Then you have also some device status data, like device temperature and internal humidity as battery voltage, and error and status codes. If you scroll over the error graph, you can actually see what kind of error or warnings appeared during this timing block. Now these graphs are some kind of summary. You can here also see which of your sensors are actually online and sending data. Now if you scroll down below, you have some additional graphs for each single device. If you would like to show actual data full screen, for example on a tablet, you can go to this graph and select View on the top. Make sure you have selected a decent update interval on the top right, otherwise you will not have actual data in the graph. With the arrow on top left, you can go back to normal mode. Furthermore, if you get data over a mobile phone or a gateway with activated GPS, you can see the actual position or the track within the selected time period inside the small map here. On the opposite graph, you can see the LDSA values linked to the GPS position. By sliding along the LDSA values here, you can see the corresponding position on the map. You can see the sensor was slightly moving, and you can go and check where the high concentration occur. We can dig here shortly a bit deeper. For example, we can mark here some peaks in the LDSA graph. If we zoom in the map here a bit, we see that we are arriving here at the train station and are faced with concentration peaks caused by smokers standing around the train station smoking. Then we leave the train station and walk along a busy street in the city center, where we once more face higher concentration peaks. We then shortly go inside a store with low concentration, move out again on a busy street with some peaks, and then go into a quiet outskirt of the town where values once more drop. Finally, we go back indoors where we find even lower values. Now, if we open the time frame once more to a longer time interval and watch the heat map, we see here a clear pattern of more or less regularly increased concentrations at around 7 to 8 o'clock in the evening. That might be indoor cooking peaks. If we zoom in on one of these peaks, we can see that it is a residential indoor event. If we now scroll back on top and select the corresponding sensor, we can see this drastic increase of LDSA and particle number. We can see in the size graph that particles get smaller, what would be expected during cooking. Fun fact, this happens if you cook Alplermakronen, a traditional Swiss meal, and therefore use your oven. So very delicious, but very bad for your indoor air quality. Later on, you can see cooking has finished and overnight concentration drops slowly and particle size increases due to coagulation. So this is a short demonstration of an interesting event that you can now analyze in real time on this website in home office, if you like, from the edge of your bed. Now let's talk about data download. In principle, you can download the plotted data from every graph. You do so by clicking on top of the graph, select Inspect Data, and then you have the data points plotted on the graph. By clicking Download CSV, you will get this data into a CSV file. The tricky thing here is that this is not the real raw data, but there is a good reason for that. If you select the time interval, for example, of about 2 weeks, there are not enough pixels on the x-axis to plot every single data point. So the interface actually looks how many data points can be plotted and then decimates the data with averaging to the number of data points that can be displayed. So if you download data here, you will get an averaged summary of the data within this time interval. The advantage of that is that you don't request a high amount of data from the server. You cannot plot anyway because the limited resolution of the x-axis. This speeds up visualization and data query on the server and reduces also data traffic. Now, what if you would like to download the full amount of data that is on the server? For that, there is a special dashboard called download dashboard. We can quickly navigate to that. Here you can now see a table of raw data in the selected time range on top right. On top left, you can once more select the sensor you would like to see. If you select here, for example, 14-day time range, you can see that the table takes some time to refresh. The averaging function here is disabled, so it takes more time to load all the data. You can also sort the table. For example, that you have the latest value on top by clicking on the column description. Now here on top of the table, you can click on Inspect Data and then download CSV. When you open that file, you can see that it has a comma-separated data inside. Nevertheless, if you should have data loss due to bad wireless or GSM connection, the second-by-second values always get stored on the microSD card. So all data are also accessible in the device on the microSD card. Yeah, so basically that's how it works. I hope I could give you some insight and a little bit of education how this tool can be used. And if you have some comments or questions, go onto our website or just write us an email and we try to help. And hopefully it is a useful tool to monitor your sensor that are hardly accessible, or as I said, during times with home office. So yeah, stay healthy and thanks for watching. Goodbye.